What is the internal energy of a substance? Well, let's get down to the point, right? Of course, the name suggests that the internal energy is all the energy that the body possesses inherently, right? It doesn't include any external sources of energy. So, the internal energy of a substance, which we will call U, is the sum of what we call the microscopic potential energies, EP, plus the microscopic kinetic energies of all the particles in the object of interest. So suppose this is my object, a box of gas. We must understand that when we say kinetic energy, let's start with that. We are not referring to any kind of kinetic energy. We are referring to the kinetic energy of the random motion of these particles. And we have seen before that this kinetic energy is directly related to the temperature of this substance. So the hotter or colder this substance is, the more or less your microscopic kinetic energy will be. Okay, so basically the motion, vibrational motion or the random motion of these particles in the box. Now, what about potential energy? Well, in potential energy, we are referring to the energy due to what we call the intermolecular forces between these particles, right? So when they are sufficiently far apart, these intermolecular forces are usually attractive in nature. Okay, I'm just trying to see how I can draw. Well, there'll be lots of arrows to draw, so we won't waste time with that. Okay, so it's almost actually quite similar to the idea of gravitational potential energy, which in that sense means that this thing is actually negative. Hmm, right? And that is also why, right, when we talk about ideal gases, okay, the particles are so far apart that they're infinitely far apart that we say, maybe I should write this down, that for an ideal gas, okay, EP is 0. And so this will be a very important concept. The internal energy of an ideal gas is only equal to the sum of its microscopic kinetic energies. All right. So anyway, this is the concept of internal energy. It is the sum of the microscopic PEs and KEs.